Well, thank you again, everyone, for joining us this afternoon. My name is Erin Judge. I'm the program manager for alumni events at the College of Engineering and Applied Science. And I'm very excited to be here today with the incredible student team behind the award-winning SPARC House from the Solar Decathlon Build Challenge for this next webinar in our alumni webinar series. Now it's my pleasure to introduce the student team behind the SPARC House. They're actually joining us live today from the home in Fraser, Colorado. So this is a very special opportunity to get this inside look. I know some of our student team members have actually since graduated and they are now alumni of our college. And I just want to say thank you to all of them for taking the time to share your amazing work with our alumni and friends today. So to get us started, we will first hear from co-founders and project leads, Gabi Abello and Hannah Blake. Gabi and Hannah, I'll go ahead and turn it over to you.
Hi, thanks for having us. And thank you guys so much for being here and for taking the time to show interest in our project. We're really excited to share it with you. I'm Gabi, this is Hannah. So first we're just gonna get started and talk about what is Solar Decathlon as a competition. So with the Solar Decathlon, it has two main paths in the competition. There's the design challenge, which features, I believe it's a 1-year competition where student teams basically design buildings that are net zero and highly sustainable. And it can be in a range of different purposes. So, they're like commercial or education, things like that. So there's that path. And then what we did was the build challenge. That focuses on the design and build of a fully functional home that has innovative solutions to, climate change issues and other issues that we face in our communities. So that's kind of what we did, and it kind of forces us to take a closer look at the processes of how these houses are built, the replicability, and the cost of everything. So the competition is basically judged then on 10 different contests. And these are the contests that you see on the screen. So we have everything from energy and engineering to architecture to the marketability of the home, and even the innovation of it and the presentation and community outreach throughout the project. So it was a 3-year thing.
So CU Boulder has competed in the Build Challenge in the past. We actually competed in 2002, 2005, and 2007. The first 2 times we competed, we won both, which is amazing. And in 2007, I believe we placed top 5. But this past year, we decided to compete again, and we'll tell you a little bit about the team origin story after the house tour. But we were really excited to come back and win it again this past cycle. So this year, the competition looked a little bit different than it has in the past. There was the option to do a local build. And then because of COVID, actually all of the teams were required to do a local build. This year, the virtual village served as a place where the public can tour the homes. And in the past, the homes had been shipped and built on the National Mall. But we think the competition did an amazing job of creating this great virtual environment, and the public can still go and tour these homes virtually on this platform. So our team over the last 3 years has consisted of about 20 core members, but over 75 students have been involved in the project over the 3 years. And so many industry professionals and faculty have been involved as well. So it's been a great team effort. And it has also been a very interdisciplinary team. We've had students from almost all of the engineering disciplines, as well as the environmental design program that CU Boulder has, and the business school, and the arts and sciences school.
So now we're going to take a quick tour of the house virtually with Charlotte, and we're going to pass it over to her.
Hello, my name is Charlotte, and I'll be giving you a tour today. So onto the house. This house is really unique because it's designed for real people in the real town of Fraser, Colorado, where we are today, which is unusual for the Solar Decathlon. And It's one of the coldest places in the entire lower 48. Now, designing an efficient all-electric house in one of the coldest climates in the US has allowed our team to set a precedent for sustainable housing. The 5 pillars of the SPARC house design philosophy are sustainability, performance, attainability, resilience, and community, which is the acronym of SPARC. And as we take you through the house, you'll see how these different elements come into play. Now, as a team, we decided to focus on the concerns of communities within our state. Mountain towns specifically are seeing an attainable housing shortage that has displaced seasonal workers and middle-class families, both of whom are vital components to the local economies. Now, many of us visit these ski towns during vacation in the on-season, but what happens during the off-season? There are people who live in these towns full-time and are all too often overlooked. Now, because of the cold climate, the build season's really short, and with a universal skilled labor shortage, the focus of development has understandably shifted to high-return luxury second homes. Additionally, building materials are often far less accessible to more remote mountain towns, and all of these factors together drive land and property prices way up and push people out. So our approach to confronting these issues is threefold. The first is the rental unit, one of the most unique elements of this house. It essentially serves as an attached, locked-off space that homeowners can rent out to seasonal workers. Secondly, you're going to see a number of systems integrated into the house that balance its livability with efficiency to keep occupants safe, comfortable, and healthy. And the third strategy that we used is prefabricated panelized construction. We were lucky enough to partner with a local company called Simple Homes that fabricates house panels in a climate-controlled warehouse in Denver. And by working with them, we were able to explore the idea of constructing highly insulative and durable wall panels that have multiple layers of Havelock wool insulation and weather and vapor barriers. These panels were then brought to site and put together like a puzzle to construct the house. And as you can see in the video, we built these wall panels at Simple Homes. This was about a year and a half ago now, and they were set on site by Simple Homes in just 2 days this past fall. This prefabricated panel approach really helps to address the affordability and the short build season. And in this next slide, you can see which part of the house on the right-hand side is the main unit and the left-hand side is the rental unit. And now we will begin our tour of the SPARC house, our award-winning net zero all-electric home suited for the coldest place in the lower 48. So each elevation of this house is created by, as I mentioned, separate prefabricated wall panels. The panels are connected by structural ties, a weather barrier, continuous insulation, and pine tarred siding, which is set on furring strips to create a rain screen that allows for drainage and evaporation, ultimately protecting the structure from the elements. Another unique aspect of our house within the context of the Solar Decathlon competition is that it is 2 stories tall. A multi-story house can fit far more living space onto a smaller plot of land, which is, as I mentioned, a very expensive resource in these mountain towns. And it also allows for a separation of the interior spaces, so there's still a clear distinction between private and shared areas, even within such a small house. Other benefits of the 2-story house include better access to daylight, views, and natural ventilation. So the solar panel production is far less affected by shading from trees, for example. The 2 main roof pitches of the house face southeast in order to increase production from the 7.6 kilowatt solar system on the roof. And the roofline orientation and solar panels may be the most visually apparent sign that the home is net zero energy, but our focus was first and foremost on the energy efficiency of systems within the house to make sure that the house performed as well as possible before just slapping solar panels onto it. The SPARC house's exterior walls, for example, are over 1 foot in thickness. And in addition to the continuous mineral wool siding or insulation behind the pine siding, there's also sheep's wool inside of the 2x8 framing structure, which creates a highly insulated envelope for the home. And the Alpen windows are strategically placed for access to views, daylight, and natural ventilation. Now, these windows are quad pane, which means that there are 3 gas-filled chambers within the overall window, and that gives us really high thermal performance. Now, before we go inside, I want to point out a couple of the material choices we made. The roofing is standing seam metal, which is a really durable material, and of course, a very important consideration for the harsh Fraser winters. And the pine tar coating on the beetle kill wood adds a protective layer to the siding while also highlighting a fun piece of mountain town history, which is that pine tar is the earliest known wood preservative that was applied to skis to prevent water absorption. And out here, we've got 3 Mitsubishi electric single zone cold climate heat pumps. What a mouthful. The outdoor units are all strategically placed in order to provide short runs of refrigeration line to the indoor units. This choice also allows for use in each area of the house as needed without standby energy losses, and for each zone's heat pump to be correctly sized in order to maximize efficiency. Cold climate heat pumps are a newer technology that leverages inverter-based compressors and compressor cooling through the use of waste heat. And they provide about 1.5 to 5 times of the heating capacity compared to the amount of electricity needed, even in really cold temperatures. Now, using the door on the right here, renters will enter their home through their own private entrance, and the rental unit, as mentioned before, allows the homeowners to support their community by housing seasonal workers. It also acts as a supplemental form of income that can be used to offset the mortgage cost, and this space provides flexibility because homeowners can really grow into their house and decide to use the space for other reasons later on. As you can see, this unit is designed as a studio space with its own kitchenette and beautiful sweeping views of the surrounding mountain ranges and plenty of daylighting. So now we'll head over to the mechanical closet. We designed and built our house to be airtight, meaning that it has very little air leaking at windows and other wall penetrations. And this Renew Air energy recovery ventilator on the ceiling allows us to introduce the right amount of fresh air as needed. It brings fresh air from outside and exhausts stale air from inside of the house, and both streams of air pass over a heat exchanger so that the indoor air can be warmed using waste heat from the exhaust air. And we also have this water heater, which is an electric tank water heater, selected in part for its ability to store thermal energy, which means that the house can participate in utility demand response programs or align water heating with solar panel electricity production. We also have an energy meter situated on the wall here, which, not to brag, has shown us already that the SPARC house is producing more energy than it consumes for a typical mid-year day, even though at the time temperatures were below freezing. And while not shown on this tour, this mechanical room is one potential location for energy storage. Our house is resilience ready in that it is designed for the addition of a 16 kilowatt hour modular battery system, which can be connected to the solar edge inverter, which sits just outside of the wall of the mechanical room. Now, before we move on to the main unit, we're back in the rental unit, and I want us to note the WAC electric lighting fixtures. The design intention for using these downlights in the soffit and all these sconces is to prevent unnecessary penetrations in the air barrier, which sits just behind an electrical chase, just behind the drywall. And now onto the main unit. On this level, you'll see the open living space and full kitchen with high efficiency Energy Star Beko appliances. An important design strategy that we wanted to largely uphold is the use of a wet core, which means that we tried to keep all of the plumbing systems as close to the central demising wall as possible in order to limit the length of hot water and duct runs. Now, right across from the kitchen, you do see a half bath that sits underneath the stairs, really just for space efficiency and occupant practicality. Also under the stairs, we have this lovely reading nook that sits just above a crawl space access door. This crawl space is 4+ feet tall and spans the entire footprint of the house, which allows for a lot of great storage opportunities. And in this main space, the tall ceilings not only improve the feel of the space, but also allow for vertical storage opportunities. As we go upstairs, you'll notice one of the 3 indoor heat pump units that's connected to one of the outdoor units that provide heating and cooling to the house. And immediately, once you reach the 2nd floor, we're in a flexible sort of space that currently is designated as an open office for the homeowners. This type of high set window that we have right next to the office space appears 3 times along the south facing wall and 1 time at this level on the north facing wall. Now, all of these windows are operable, which makes them really great for passive cooling in the swing seasons and during warmer summer nights. And an added advantage of these windows is that their height allows them to perfectly capture the scenic mountain views while blocking out most of the neighboring houses. This also adds a sense of seclusion and protects the homeowner's privacy upstairs. And we also want to point out that the SPARC house's entire north facade has only 2 windows. This is important because we had to achieve a balance of capturing the beautiful north-facing views while also minimizing the openings for fenestration. And this helps to maintain the thermal integrity of the single coldest wall in the house. And over here, we have a stacked washer and dryer. This is a heat pump dryer, which means that there's no need for a vent penetration through the house's envelope. And finally, we enter the main bedroom, which has a lot of natural light from a combination of the windows and the mirrors. From the window above the bed, our clients, Kristen and Joe, have shared that they can see the Continental Divide during the day, and at night, they can see the stars from the comfort of their own bed. They've told us that this is an absolute dream come true because they are able to live in a house that connects them to the mountains while addressing our current climate crises. And most importantly, this house represents a sustainable, viable option for a lot of people. The all-in costs are roughly $440,000 for 2 new living options in Fraser and has a rental income estimated at about $800 per month. And it's very easily replicable in other places because panels and system sizes can be changed for unique sites and climates. And now back to you guys.
Thank you, Charlotte. That was really awesome. So now Gabi and I are going to tell you a little bit about the team's origin story, and then we will hear from the other team members about some of the challenges that we overcame to build this house.
Yeah. So we'll start it off. I mean, I think one of the biggest things with our project and one of the most unique aspects was the fact that we had clients that we were working with from the very beginning, and that kind of ties into our origin story. So basically, in sophomore year of college, Hannah and I we went to tour the 2017 Solar Decathlon competition that was actually held in Denver, Colorado. And we got there, we saw all of these student houses, you know, built up, and it was amazing. The second we saw it, we were like, this is so cool, we have to do this. And we were literally touring the very first home that we stepped into and talking to each other about, you know, why doesn't CU have a team? Like, I don't see any Colorado houses, you know, we should really get a team going. And a couple overheard us. So you want to take it?
Yeah. So we were touring a house talking about how CU had to participate in this. It was the coolest thing we'd ever seen. And Kristen taps on our shoulder and says, if you guys create a team, let me know. I really want one of these houses. And I mean, that was really crazy and awesome. And we were like, we'll be in touch. We'll talk to some faculty. We'll try to make it happen and definitely let you know. So we get back to campus, and over the next few months, we look more into the project and we learn about CU's history in the project. We interview some of the past competitors and faculty advisor and start to just form a group of interested students. And we're buying pizza with our own money just to have our friends show up and like make this club look like it's a real thing. And traction just starts to build, and it's a kind of a snowball effect. The team grows and grows, and Jennifer Scheib, our wonderful faculty advisor, gets on board, and we reach back out to Kristen, and Gabi actually emailed her.
That was 1 year later that I emailed her again, and I just said, you know, it's been a while, and I don't even know if you remember me, but if you're still interested, we'd love to build you a house. And she emailed us back within the hour, and from then on, it was history. I mean, we wanted to work with the client because we knew that it would have kind of like a bigger sense, like a impact that we felt like we could grasp, and we could kind of look into more a community then and really try to get inside the needs of these people that live here and everything. And that was very unique to us. And you're not required to have a client in this competition. And of course, there are challenges that come with juggling the competition requirements and clients, but it was so well worth it. And I think it actually got us to where we are now, of course, and we're so grateful for that. So that is, you know, the origin story for us, and it's pretty serendipitous, but yeah, we're so happy it happened.
Yeah, I would say that coming from CU, we know so many people who grew up in mountain towns or at least visit every single year. And so I think that being able to address a problem that is so close to our homes and our hearts and our families was a really amazing experience. And we are happy to spread awareness about the housing crisis that most Coloradans do know about, but on a national level or an international level, it's maybe not the most talked about thing. So it was really cool to see the spotlight that this issue and also just sustainable building methods in general were able to get from this competition and from our doing so well in it.
Yeah. So now we'll pass it on to our other team members. Justin, if you want to start, and then we kind of will move over there, migrate over there as well.
Awesome. Hey guys, I am Justin. I am the structural engineering lead for the team. I've worked on this project for about 3 years, and I just wanted to share something that was very challenging for us to overcome. So we had to work with a lot of different authorities and a lot of different project demanding entities to overcome the actual design requirements for this project. And those were the city of Boulder, the city of Fraser, the University of Colorado, and of course the actual project, Solar Decathlon project. And to overcome all of that, we had to balance the wind loading in Boulder with the actual cold snow temperature and snow loadings in Fraser. And on top of that, we had to build very thick walls to help out with all the insulation for the project. And at the end of the day, we managed to overcome all that. And yeah, I'll pass it off to Ash.
Yeah, I think similarly, Justin worked on the structural engineering side of things. I worked on the system side of things. So that meant the electrical and HVAC design for the house. And I think the challenge that we had as a systems engineering team was working with the local authorities, working with the plumbers and the electricians who had an idea of how things had previously been done and how they had been doing them very successfully for 50 years or however long they had been in the trade, and kind of changing their minds about things and presenting new ideas was pretty difficult. But I think overall we were happy with the combination of the new ideas that we brought to the table and also like the very practical advice that they had helped us out with. Do you want to go, Charlotte? You have a
I don't have.
No, yeah.
I can talk about COVID.
Yeah.
When COVID hit, obviously that threw a wrench in all of our plans. We had to figure out how to organize people to work on the house while also maintaining COVID safe standards and guidelines and stuff. I would say we relied a lot more on Kristen and Joe. They really worked incredibly hard on this project with us. And we had to start coming out here because we built the house in Fraser rather than at CU initially. So we had to plan how to come out here, how to work together while also social distancing and wearing masks and all this stuff. Mm-hmm. So that was a big challenge, but we did it. We made it through.
Yeah. We actually had students living up in Fraser. One of the general contractors who is local to the area and was helping tremendously with the project had a condo that he let some of the team members stay in. So there were some team members actually living in Fraser for a few months during the fall and spring, doing some construction, and that was a really cool opportunity for the students to spend some time in the mountains and really be completely surrounded by the environment and get to know the local community better. So I think that definitely strengthened the project and morale as well. It was just a really good way for the team to feel really ingrained into the community throughout the project. So that was, I think, a blessing in disguise when that changed from COVID.
Yeah. So now we can go ahead and get into some of the Q&A questions. So if you guys have any questions for us, just go ahead and throw them in the Q&A thing, and then we're going to try to read through and answer what we can. And if we don't answer your question during this webinar, you can always email us at Solar Decathlon, right?
Yeah, at Colorado.
solardecathlon@colorado.edu, and we'll answer your questions there too. So yeah.
Came in about cost, so we start with cost.
Yeah.
Well, you want to start with the SIPs question because someone asked that in the go.
Yeah, so I saw a question that was asking whether the panels are SIPs. They're all actually stud wall panels built in a factory in Denver. And we did that because that's the biggest, or that company does that because that's the biggest cost add they could do and balance customization and other project factors.
Awesome. Yeah.
Yeah, and SIPs, due to the insulation that SIPs uses, it has a much higher carbon footprint. So the sheep's wool insulation that we were able to use because we did the traditional wood framing with the non-traditional prefabricated method, we were able to lower our total carbon in the wall's structure greatly with that.
Yeah, so I want to answer this question live also. So the square footage of our house is 1,200 square feet, and it's basically 3 different modules that we have stacked. So 1/3 of that is the rental unit. And to talk about the total price was all in $440,000. And when you're looking at stick built comparison, we have to understand like the specific circumstances of the site and everything. And as we mentioned with mountain towns, when you're building stick built, especially in a place that has a really short building season, that can last like many, many months because you can't really build during the winter, and the winter is like 3/4 of the year here. So it's pretty cold and weather doesn't allow that. So with what we did and panelized construction, we were able to build all of this in a factory very quickly with highly efficient and like precise technology and everything. So we're cutting that construction time by a huge amount. And because of that, the cost like per square foot comparison and everything, it doesn't really do this house that much justice because it is a small piece of land and it's not a lot of square footage. But with what you're getting here and the high efficiency and the high quality of materials and everything and how fast we can put this up, it really comes out to just being like well worth it. Not to mention how much you're saving monthly with your utilities and everything like that, because we're pretty much just net zero, and that's amazing. And not a lot of houses can say that here. So
I can help moderate some questions too if you'd like me to.
sure.
Yeah, sure.
Awesome. Cool. So we've actually had a lot of questions come in about replicability, and I know Charlotte, you touched on this a little bit. So one question from Kim was, do you think this type of build can be efficiently replicated for multifamily housing, i.e. for attached townhomes or condos for affordable housing development?
Yeah, that's a really good question. And I think that throughout the entire design, replicability was one of our biggest focuses. So it was one of our priorities from the very beginning, and definitely a pillar of our design that informed a lot of our decisions. And one of the decisions that replicability informed was the 3 modules that the house architecturally contains. So we have 3, actually, I think it's 14 by 28 foot boxes essentially And the dimensions of each box is so that the box itself could be shipped on a shipping container truck. So that is a possibility with the dimensions and the design and everything. We didn't build it that way because we had the prefabricated method, but because the 3 modules are could be independent, we could definitely see a future of mixing and matching the modules in different orientations to accommodate different family sizes or different housing development styles, whether it's attached townhome type style. We could definitely see that being possible.
And touching on that a little further, Simple Homes, the company that we worked with that builds the panelized wall sections, does a ton of multifamily work in Denver. They're developing backyard suites, full houses, and multifamily housing in Denver currently, just to show that the panelized wall systems really do work really well in practice.
And I think we can roll into that one question we have that is about what is the next step with our design. And essentially right now what we're trying to do is just make it accessible and public. And we've already had conversations with multiple people who have reached out that are interested in building something similar. And that's huge. And we would love to push that forward and to encourage people to use what we have and make it better or make it your own or improve on certain things. Even the fact that our solution had 3 different aspects to it, those 3 things can be, used separately if they want, because there's the panelized portion of it, which is going to help a lot of people in different places. There's the efficient technology, which is going to help people who want to renovate or, upscale their house and make it more efficient. And then there's the rental unit, and we're already seeing that become more popular even during the pandemic with people that want to have another accessory dwelling unit or something similar on their property, something to rent out, or other cubicles on their property that they can go to for work or for an isolated family member or something like that. So that's kind of the next step. And we've also heard Simple Homes, the company that we worked with, they're interested in pursuing more projects in mountain towns, and that is huge. And we want to encourage that also as well.
Great. I see a couple questions that have come in kind of around the heat pumps that you use. So the first question is, were geothermal heat pumps considered? And the second is, what is the lowest temperature in which the air source heat pumps can operate, and do they need an electric resistance boost for extreme low temperatures?
Yeah, that's a great question, something that we consider a lot when designing for such a cold climate, because heat pumps are newer and they're typically not really used, or you're not really seeing them in cold climates. A lot of people use them for air conditioning. The geothermal heat pumps, we considered them. They were a little bit cost prohibitive. There's a lot of site work that has to be done to dig the wells. You have to do like a little bit of geotechnical engineering to make sure that you're digging the wells in the right spot structurally, and all that other stuff. The other issue is that we had originally planned on building the SPARC house in Boulder, disassembling it and then moving it up to Fraser. And in that scenario, it just was infeasible to do geothermal wells twice. And then the last bit of that question was, what was the last bit of that question? It was what's the cutout and the coldest temperature that they operate at, which is, I believe these Mitsubishi heat pumps are rated to -14 Fahrenheit off the top of my head. And they do have an electric resistance backup, which was also a very challenging design question, because if you give the electric resistance, if you install electric resistance in the house that would keep the house at, say, like 75 in the winter, that actually caused a lot of problems for the local electric utility, because so many of the houses up here are on electric and gas that their transformers were simply too small to handle the load of the backup electric resistance heat. We were really lucky in that we were able to work with the owners and the first occupants of the house, and they were okay with saying, like, hey, like in an emergency situation where it's below -14 outside for like an extended period of time, the heat pumps have cut out and they haven't been on for like a day, like we're okay with, going with like a safety minimum of, say, like 60, and that'll keep everyone safe and it'll keep all of the pipes from bursting, but it isn't necessarily going to cause issues for the electric utility. So that was the kind of design philosophy that we went with.
Great, thank you. Another one that I see here from Bruce, how did you avoid compression of the sheep wool insulation?
That was an interesting thing for us, actually, because initially our plan was, you know, when we're making the panels in the factory, we're putting the wool in and we're closing it up, and then we are shipping the whole panel to the site and putting it together. And what we noticed when we got on site was that that didn't really go as planned, and the wool was compressing in transport and everything like that. And you don't want to compress that wool. You want it to be kind of fluffed out and everything to have the best function. And so we kind of had to go through again and redo the wool a little bit and make sure that it was all where it was, you know, together and not too compressed or anything. So what you do is you use a staple gun basically, and you are stapling it to certain places, trying to fluff it out kind of thing. So, and you're making sure that, you know, what you're putting in the wall is like a certain R value. You're not putting too much of anything. And our wall cavities, our wall is like 1 foot in thickness. So there was plenty of space to like make that work and everything. So that's how we avoided compression.
Great. So another question came from Bruce. Could you talk a little more about the pine tar finish? It's a cool and historical idea, but what do we know about longevity and needed care as we move forward with that?
So the pine tar siding has a 10-year maintenance limit on it. So that's a pretty resilient option. It's also a sustainable option because we were able to use beetle kill pine, which is a local resource, and it's weather resistant. So it's a good for waterproofing and water resistance. So yep.
Great, thank you. So we have another one that came in from Davis. He says, I joined late, so I may have missed this. What kind of energy storage is being used, and is it able to supply all of the home's energy needs through the night?
We talked to so many different battery suppliers for this one. So I guess like to quickly answer your question, the home is on grid. So it, in theory for the Solar Decathlon project, the design intent is to have a house that could be islanded for a set number of hours. I think it's 48 hours off grid. This specific house, for the competition, we put in a temporary battery installation to show the Solar Decathlon judges that like we had gone through all of their hoops. We had designed a building that would meet their standards. And then we told them we talked to so many battery suppliers and no one would install a battery in a town with such a high elevation because none of their batteries were warranted up here. And then additionally, no one would come out to Fraser to be like a certified battery installer. So
could I add one thing there?
Yeah.
We are on the waiting list to get the Ford F-150 Lightning, which has a 100 kilowatt hour battery and vehicle to grid capability. So our plan is to upgrade the charger to a two-way charger and use the vehicle also as backup power.
Nice.
Yeah.
Was that able to be heard through Zoom?
So the new plan is basically as a backup to do vehicle to grid. So the homeowners, Christian and Joe, who've just joined us off screen, have told us that they're planning to get a Ford electric truck, and that will be able to power the house. I think Ford is saying like that they're going to be able to power a house, like a typical home.
We've estimated
which
even
this
in the
house
winter,
isn't
we
even
could be off grid for 3 days.
Yeah.
So that kind of backup.
Well, that's because we have a more energy efficient house.
Of
So
course.
well, and that
We'll go tell Ford.
the Decathlon requirement.
That's great. That's awesome to hear. A really interesting question came in from Joanne. So she wants to know a little bit more about the Solar Decathlon challenge and some of the other competitors that you were up against. So can you tell us maybe a little bit about some of the other teams that came in, you know, maybe top 3, and then what really made the SPARC house stand out as the winner?
Yeah, I can talk about some of the competitors, I guess. We competed against Las Vegas. They built their house for a veteran. And so that was very interesting because there was a lot in that house that, you know, focused on certain triggers and certain things that, you know, would affect veterans more. And we don't really think about that when we're building.
From an architectural standpoint, it was really unique.
Yeah. There was also CU Denver, or DU. Sorry. DU had a house renovation project. So that was really cool and new to the competition because they were taking an existing home and trying to retrofit. And I think that would be a really cool thing to see more of in the competition, hopefully in the future. So that was unique. I do want to say too that I think with everything that we've done here and the amount, we did put a lot of effort into understanding the community and really making something that not only is efficient and sustainable in the environmental, you know, aspect, but also economically and socially for this community. It fits here, it works here, and it can help people, which is just a step further that we were really, you know, we felt was important to take. But I think we have to understand also COVID impacted a lot of the teams in really strong ways, us included, and that kind of did have, I think it did influence how things ended up. And it's hard, you can't just deny that that didn't, you know, play a role in it. So there were teams that couldn't finish or teams that had things delayed, and there were a lot of challenges that came with that. So I think more so than how the scores came out, we're all really, really happy to be able to finish and to have this house finish this way. Like, that was amazing for us. And to have the competing teams, like, they were all really great ideas and homes. And so that was really cool. And I think it's almost semantics to say how we beat some other team because there are so many things that played a part in this competition. So
yeah, I will brag on us a little bit. So we placed top 3 in all 10 of the contests, and we actually got first place in 3 of the contests. On top of, so essentially out of the 10, you get a score from 0 to 100, and the team with the most points wins the overall competition. And we got first place in architecture, market potential, and innovation, and second place in engineering by 1 point. So we scored really well. We checked all the boxes that the juries were looking for. So we did, I believe, 6 presentations for 6 of the contests were presentation based, and 4 of the contests were measurement based. So no frills there. The organizers come in and measure certain aspects of your house, and the numbers speak for themselves. We placed top 3 in all of those measured contests. The juries were all from industry, so they were panels of 5 to 8 industry professionals who judged us based off of the score sheet. And I think that we just had really compelling presentations, really compelling jury deliverable narratives where we put together booklets answering all of the reasons that our house addressed the issues and what the competition was looking for. And I think that honestly, we just were doing our best. We didn't have any expectations. We were just thrilled that the homeowners were happy and that the house was complete. That is all that we cared about. And when we started to get feedback from the judges that they were really identifying with what we were saying and they were really understanding the story and the message, it was just amazing to see that other people cared about the issues as much as we did. And we thought that we had a great solution to it. But honestly, in the bubble of the competition, trying to complete the house, we didn't really have much time to think about what other people might think. And when other people thought that we did a great job too, it was amazing and honestly a little bit mind-blowing. But like, really, really just grateful for it. So
I think like basically to summarize, like we had people in every, I think like for most of the like sub competitions, like we had someone who was like really strong in that specific thing. And I think that was really unique because some of the schools that competed were like mostly architecture schools or like mostly engineering schools. And we had a really good, strong mixture of both.
I will also say, not knowing really truly where the other teams were at and sort of what the judges' expectations were, we were comparing ourselves to like normal houses, and we were like, we need the house to be as like architecturally nice and the interior to be as nice and stuff like that. So we weren't competing with this mindset of like, oh, we're a student group competing against other student groups. We were like, we are building a house for real people, and we need to build them as nice of a house as we possibly can. So I think we took a really comprehensive approach to that.
yeah. Absolutely.
That's amazing. Well, really well done to all of you, because we can tell that this was, you know, an amazing project. You thought of so many different things. I had a question come in here. So you mentioned a little bit, Gabi, how the DU team, you know, they base their projects off of retrofitting. And I've seen some interest in some of the questions that we received in advance and a couple coming in now that people are really interested in thinking about what elements they can incorporate in their current homes. So I guess based on the work that you've done on the SPARC house, do you have any things that you think would be very easily able to be retrofitted into a current home?
Yeah, I think one of the things to pay attention to is the envelope of the home, because the stronger, you know, the more insulative, I guess you could say, and durable the envelope, the less you need these interior systems that work so hard to make your home efficient. So with us, you know, we do have a 1 foot wall thickness and so much insulation and everything, and that's not always possible for retrofitting. But if you can add some kind of exterior comfort board or anything like that, something to beef up your wall and create a stronger envelope. Windows too, you can add you know, high efficient windows. Those help a lot with the envelope, and those reduce the need for your active systems inside the house.
Yeah, there are actually companies that will do blower air door tests on your home and determine how much air is leaking through your envelope. And if you have a significant amount of air leakage, then all of the money that you're spending on heating is just going out the window or the wall seam or whatnot. And so it is definitely, it's possible to tighten up your walls in a retrofit standpoint. You can replace your windows, you can redo the connections between the windows and the walls, and
a lot of times the baseboards. Weirdly,
yeah, that's something I even noticed
Doors.
that at my family's house in Florida. I am sitting by the window and I can literally hear that the air outside, like it's just not at all airtight. And in Florida, you're using air conditioning during the year, and just thinking about how much you're losing because of that is huge. And I think that if people paid more attention to the airtightness of their house, or, you know, the envelope in general, then we could actually make a big difference in how it performs as well.
And then heat pumps. So that's a very practical, easy installation that if you have a room in your home that's more cold than a different room, and you have a gas furnace and you're pumping up the furnace for this one cold room, but then the other rooms in your home are maybe a little bit too warm and it's just a bit of a waste. An electric heat pump is a really easy thing to install in existing homes, and they're very energy efficient, and you can reduce your gas bill by supplementing certain rooms or areas of your home with electric efficient heat pumps that do work in cold climates, as this house demonstrates.
And keeping that on, I've had trouble wanting to do a Q&A about dropout temps, so -13, 14 Fahrenheit dropout, very small backup resistance.
Yeah, so one strategy is that we actually place the outdoor heat pump units on the south facing wall so that the radiant temperature around the outdoor unit is it's going to be a little bit warmer when the sun is hitting it, especially up against the black siding. So that's a really a good thing to keep in mind, because the units do operate better when it is a little bit warmer. There's a sweet spot that is a little bit warmer than the typical Fraser temperatures, but because we placed it in a strategic location, we can definitely get better performance from the heat pump units due to that. The units are tested down to -14, but that isn't to say they will cut out below that. It really depends on the local air, wet bulb and dew point temperature of the air directly surrounding the unit, which varies when the weather says it's -14 out. It could be a little bit different if you have especially wind protection around the condenser. So yeah, those are some strategies. Anything else about the HVAC?
There's also, did you say backup resistance? Somebody asked about it.
Oh yeah, so we do have backup resistance that will keep the home at a 60-degree set point, which will prevent pipes from freezing and will keep occupants healthy and safe. That is only in times of emergency. And since the home was completed in the middle of winter, it has not been used once.
Actually, the heat pumps were installed in January and we never used the backup heat again after that.
So heat pumps were installed in January, backup heat has not been used once. So we don't expect really that to be needed because of how the home is designed to let in that heat from the sun a little bit. We have really solid walls, good quality windows. So we're not letting heat out very much. And
I guess I could add like one other thing in terms of like specifically retrofits. This is based off of like a philosophy that we had for HVAC, which is that like each of the 3 modules are a different zone. And so basically what that means is that it's like how like your mom always told you to like turn off the lights when you left a room. Like you can turn off the HVAC when you leave the room. So like if Kristen and Joe, for example, like aren't occupying the guest suite, then they don't have to necessarily heat it to be, a comfy 70 degrees. It can be, at 60. So like I saw like a really interesting product the other day that were called like smart vents, and basically they like add a fan to the vents like at the end kind of trunk of your HVAC ducting. And basically what that means is like you can pull more or less of your air conditioned or heated air into certain rooms. So that would be my only add in terms of retrofit. If it works out for you, let us know because I'm interested in it.
That's great. That's a ton of great options for people. So thank you all for kind of going through that. We are getting so many questions, which is wonderful. I think we only have time for 2 more. So what I'm going to start with is, unfortunately, we are now, coming back into wildfire season, especially in Colorado. So I see a question here that came in talking about the fire retardance and resistance of that pine tar exterior sealant, or if there's any other things that you might have considered in regards to wildfires when making this build.
So like the site, for example, like it had a lot of dead pine beetle infested trees on it. And so the pine beetle infested trees are really what is being a huge source of kindling for these wildfires. So when we cleared the site of all of those dead trees, that was kind of like a preemptive measure that we had. In terms of like actual flame retardants of the pine tar siding, like I think like once a wildfire gets to the site, there's really only damage control that you can do in terms of like not releasing more toxic things into the environment around your house. So I'm not sure that I have like a specific fire rating for that. The one thing that I wanted to add is the HVAC for the house, as we've discussed, is like a mini split unit. And what the mini splits unit it does is it separates the air conditioning and heating of the house from the ventilation. So this summer, for example, like you could reduce the ventilation. And so like from like an occupant comfort standard, perspective, you can kind of reduce the amount of particulate in the house, but still keep it cool.
I also upgraded to the MERV 13 filters, which filters out smoke, which is increasingly important in the West.
Yeah.
Definitely recommend using MERV 13 filters in any of your ventilation outdoor air systems. That is what the house does have for our ventilation, that it does filter out smoke and other particulates.
Great, that's great. So our final question here, again, I apologize we couldn't get to every single question that came through, but thank you all for submitting them. Just kind of wanted to end on this note. You all are our future leaders that will be going out into the world and kind of putting in this innovative technology that you've been working on. So do you have any advice or ideas about what you'll do in your future careers of how to get the general public or the construction industry to go green in this way?
Yeah, I think the primary incentive for most of the general public and for the building industry to go green will be behind economics. So the biggest thing that we as building professionals and the government should be working on is incentivizing green materials, efficient building envelopes, and better building practices, in turn with making the building energy grid based on renewable energy instead of old coal and fossil fuel energy. That should be the first path forward to generally getting the public to go green.
Here. And contractor and trades education, getting these systems into the mainstream is huge. I mean, cold climate heat pumps work right now. And one of the biggest reasons that they aren't being installed on a regular basis is simply because there's not many installers who are familiar and comfortable doing that. So I think that just talking about this, spreading the word and sharing articles, sharing knowledge, starting these conversations with other professionals that you know, that is going to be a big thing, I think, with just kind of propelling the movement forward and getting more people on board, installing these electric systems so that we can electrify the built environment. And we know we can do it sustainably. So really the only hurdle is getting the word out.
It's not any harder than anything they're doing already. They're just familiar with what they're already doing.
Wonderful. Well, on that note, I want to thank you all for leading the way in these sustainability efforts. We are so proud of all the work that you as our CU students and alumni are doing to improve our communities that we live in. So thank you. Thank you for sharing this amazing SPARC House tour with us and kind of taking us through your journey over the past couple of years. This was really amazing. I see tons of great feedback coming in through the chat as well. So thank you all. So thank you again to our student team, and thank you to all of our participants for joining us today. We hope to see you again soon.
Thank you so much for having us.